Hello, everyone. This is the regression analysis of credit card defaults. We're pretty much just testing out like different models. We're going to get to that later. My name is Charles.
My name is Mike.
And my name is Jones.
And we're going to be presenting again the regression analysis of data collected regarding credit card defaults. So what's the actual problem here? We collected, we gathered data, we found data regarding demographic billing and payment information for 300 different banking customers in 2005. This data was collected in Taiwan. And we're essentially measuring the likelihood that a person would default on debt. And more importantly, what regression model can be used to actually best measure that. We're doing this because we have these, we're doing this because credit card defaults are a very useful tool for both a micro and macroeconomic sense, and just as an interesting topic in and of itself, especially as we're all at the whims of massive companies and major debt hole, and we also don't want to fall into debt.
So this data set includes information on credit card customers, including their credit limit, gender, education level, marital status, and age. It also includes their payment behavior from April 2005 to September 2005, and whether payments were made on time or late. Additionally, it includes the total amount billed to the customer and the total amount paid by the customer during this time period. Finally, the dataset include whether the customer defaulted on their payment in the following month. The methodology is that the aim of the project was to determine the most effective model and independent variable to predict the likelihood of defaulting on the credit card debit. So the first few things that we did was clean the data, resulting in 3 versions of the dataset. The first version was the raw data. The second version had some variable related to payment and bills, consolidated into single variable, while the third version replaced the categorical variables with dummy variable. After cleaning the dataset, we then ran the dataset through different regression models, such as linear regression, lasso regression, and logistic regression. The linear regression was chosen to test for relationship between the variables. Lasso regression was used as a tool for feature selection, and logistic regression was used for its suitability for dataset with binary dependent variables for each regression model. The dataset was split into 2 parts and 90% of the data was used for the training model and 10% was used for the testing of the model accuracy.
Yeah, so now we can just jump into the results of the data. So actually, first things first, looking at the graph that we have on screen, we have each of the regression types broken out into the linear regression in the first 2 sets of columns, lasso regression in the second 2 sets of columns, and logistic regression in the third set of columns. And then each of the columns represents the original data, which Jones had mentioned, which was the raw data set as we got it from the website, that once it was cleaned. Then we have the orange columns or the orange bars, which are the consolidated data sets where we had taken a couple of the columns, such as the payment information, and consolidated it. So instead of a 6-month view, trying to see if the payments were more than the bill each month or less than the bill each month. So if they were falling behind more. And the third data set is going to be our original data, but instead of using a lot of the categorical values that were already in there, such as 1, 2, and 3, 4, and 4 for education, we ended up breaking that out into separate columns for dummy variables so that we had a column for each of the different education levels that were being tested for. So first, starting with linear regression, you can see that for the training data, we're averaging around 13.4%. R squared, so only 13% of variability was being explained by this model, which is definitely not a very successful model. And even with the test data being slightly more successful in that prediction, it still was not a good result, which is why we then moved on to lasso regression, which provided even worse results across the board. It basically cut the resulting R squared value in half from that 13 to 15% down to about 6 to 7% range. So across both of those data sets, the consolidated data really was not producing the best results for these groups. So we figured out that the consolidated data was probably the worst way of handling this data and was not going to be impactful, which we again then saw once we moved into logistic regression, where we saw our greatest success, where both in the training and test data, we were averaging 80.9%, or even in a couple cases, depending on the sampling methodology we used, up to maybe 81% R squared values. So we were getting about 81% of the variability explained in the model. But once we move on to the next slide, we're actually going to look at some of the challenges that we did encounter once we got into those models. So as I mentioned, with linear and lasso regressions, we produced some pretty poor results just by using those. They're really not well suited for having a binary response variable or a binary dependent variable, such as this, where we're just saying, did they actually default on their credit card debt with a 1, or did they not default with a 0? So taking those aside and really focusing on the one that produced the best results with the logistic regression, the reason that although it looks very good by comparison, where we're getting 80% of it resolved, the biggest issue is that it's not identifying the customers that were defaulting as successfully as you would want it to. So of customers who didn't default, we were able to have that model predict with 97% accuracy. The customers that didn't default, it predicted that they wouldn't default. But for the customers that did end up defaulting, we were only predicting that correctly 24% of the time. As you can see on the right-hand side, looking at the confusion matrix, we only successfully predicted that with that model 1,500 of the people that ended up defaulting, as opposed to the 4,300 that were predicted to not default that actually did end up defaulting. So in a real-world scenario where we're running this with actual data, almost 3/4 of the people that were or customers that are included in the model, we would have said that they weren't going to default when in fact they did. So overall, this definitely is not the perfect scenario. And on the next slide, we're going to talk about some other studies that have been done that have been more successful.
I guess I can move on to the conclusion, but just even off of this kind of thought that even like if this model is used for predicting like 90% accuracy for people that don't default, that's still relatively useful information. Like that's still not a bad outcome. It's not the more interesting of the outcomes, but at least it gives us a way to measure again, like provide some minor amount of information there that might actually be useful if by making any sense.
Absolutely. But I think the big thing that we would want to identify in the future is going to be who defaulted and make sure that we're classifying those more correctly, because that's where all the risk is.
Yeah, that's the actual, that's the moneymaker, for lack of a better word. So I'll move on to the conclusion then. Oh, sorry. I didn't know there was other stuff here, so yeah.
Yeah, not a problem. That was just circling the false positive rate that we were having.
Okay. So our conclusion again that the best model we were able to get out of this was a logistic regression model with about 81% overall explainings of the variables mentioned before. Again, we had poor overall performance for all 3 regression models, given that the linear and lasso regressions had low R squared values, and the logistic regression had a high false positive rate. Again, the most successful method was to use artificial neural networks with a coefficient of about 96.5%, which is in from a study actually from the source material from this data of Ye and Len in 2016. Again, we believe that going forward, or if we were to redo this project assignment again, we would definitely use stepwise regression to help, figure out what variables are actually the most important and use those to create a stronger model using stepwise regression or even like forward or backward selection. Long and short is we did add a piece to a much larger puzzle, and with continued work, we can develop better tools to make businesses and people make better financial decisions. Normally, this is where I would say, if you have any questions, that'd be the time to ask them. But given that this is a video, we kind of can't do that, at least not directly. Thank you for your time. Here's the site that I mentioned before in our references section.